In this video, we are going to talk about node voltage analysis. And with this method, we can find voltages, currents, powers, and many other parameters that may exist in the circuit. So let's begin and talk about this method with this example. The first step that we're going to do is to choose the reference node. So first of all, we need to choose a reference node. The second step is to label node voltages. And the last step is to write KCL, or Kirchhoff's current law. Okay, so let's look at the circuit and see what are the nodes. So we can say that this is our node, the first one, this is the second one, this is the third one, and also we can say this is the fourth node. But we can contract it and to a single point. So because they are all in the same voltage, we can say this is our fourth node. So we can choose one of them as a reference node. So we can say that this node should be a reference node, and we can connect it to the ground, or we can say it is in the 0 voltage, and label them. So this is E1, E2, and E3. Okay, we have done the step 1 and 2. Now let's go to step 3. We should write KCL for each node. In node 1, okay, look at the E1. We have some currents. We can write some currents that going out of the E1, like this. This current, as you can see, we can write it as minus IS. This current, we can write it as E1 over R1, right? Because of the Ohm's law. Remember that Ohm's law says that V is equal to IR. And from here, I will be equal to V over R. So the potential difference between E1 and the ground is just E1, because there is a resistor here. So the currents should be E1, the potential difference between these two nodes, which is E1, and then the resistor R1. And for this current, we can write E1 minus E2 over R2. Because remember that the current will always flow from the high potential to the lower potential. Okay, so if our current is in this direction, which is going from E1 to E2, so we need to write E1 minus E2 over R2. Now, let's write the KCL. So for node 1, minus IS plus E1 over R1 plus E1 minus E2 over R2 will be equal to 0. And we will do the same procedure for each node. Let me clear these parts. Okay. For node 2, we will have the same procedure. This current, we can write it as E2 minus E1 over R2. This current, we can write it as E2 over R3. And this current will be E2 minus E3 over R4. So therefore, we have E2 minus E1 over R2. We're writing the KCL relationships, and plus E2 over R3 plus E2 minus E3 over R4 equal to 0. Also note that, okay, let me clear these parts because it is too crowded here. All right. Also note that E3 is equal to Vs. So we have another thing that E3 is equal to Vs. By the way, please note that whatever I have written in the black in this circuit, they are known. So we know the values, we know what are, but in blue we don't know. So we need to find the E1, E2, and E3. So we said that E3 is equal to Vs. So Vs is known, so E3 is known. So we know this. So we can write, okay, in these two equations, Is, R1, R2, R3, R4, Vs, they are known, right? They are known. But what we don't know is E1 and E2 are unknown. So therefore, we have two unknowns and two equations. So we can find the E1 and E2. From here, E1 and E2 will be known. So let's go to another example and see other conditions that we may encounter in the questions. This is another example. So let's look at it and approach it with the node voltage analysis method. So let's look at and see what are our nodes. These are our nodes. This one, these are our nodes. And let's choose the reference node. Let's choose this one as a reference node because it would be much more easier to deal with this example. However, we know this reference node is just known. It is VS1. So we don't need to be worried about it, and it is just known. Okay. Therefore, we can write this as one E1, E2, and E3. Hence, we will have three unknown node voltages. However, this example is a little bit different than the previous example. You can see that we have voltage source between two nodes in this circuit. Whenever you see independent or dependent voltage source between two nodes, we can consider the whole part as one node. Well, what I mean by that is we can say that this two nodes and the voltage source between them as one node, and we can call supernode. Okay, let's go and write the KCL. For supernode, what are the currents that are outflowing? This current this current. These are the currents that are outgoing from this node. So for this one, we can write E1 minus Vs1 over R1 plus this current is E1 over R2 plus this current will be E2 over R3. And finally, this current is E2 minus E3 over R4 equal to 0. And another KCL equation for node 3. We would have, let me clear this currents here. Okay. For E3, we have these currents that going out of E3. This current will be equal to E3 minus E2 over R4. This current will be minus IS1. And finally, this current is equal to E3 over R5 equal to 0. And whenever we use a supernode in our example, we need to put some conditions. So our constraint is that E1 minus E2 is equal to Vs2. So we have 3 equations and 3 unknowns. Equation number 1, 2, and 3. And by this, we can find E1, E2, and E3 easily. In the next example, we are going to see some numerical values. And let's go to another example and see what it brings us. This is the last example. And let's look at it. And okay, in this example, we need to find the power absorbed by the 3 ohms resistor. So with node voltage analysis, we need to find the nodes first of all. So let's look at what are our nodes. This is the first one. This is the second one. Third one. And this is the fifth. Therefore, we need to also choose one of them as a reference node. If we choose this one as a reference node, it would be much more easier to deal with this example. And let's label them E1, E2, and E3. Like previous example, we can see a dependent voltage source between 2 nodes E3 and E2. So we will consider this part as one supernode. Supernode S. I call it S. Okay, for node 1, the currents that are going out of it are these. So we can write them. -5 plus E1 minus E3 over the resistor, which is 2, plus E1 over 4 plus E1 minus E2 over 2. So as you can see, we can decompose this current as two currents. One which goes to the upper and the other one is going to down. So this one will be -5, which we written here. We have written it here. And this one is E1 minus E3 over 2 ohms, which is this one. Okay. So it's simple. Let me clear these parts. For node S or supernode, these currents are going out of it. So we had E3 minus E1 over 2 plus E2 minus E1 over 2 plus E2 over 3. Oh, by the way, these are equal to 0. And our constraint equation will be E2 minus E3 equal to Vx. And also we already know E1, we already know that E1, equal to Vx. So from this, we can derive E2 minus E3 equal to E1. So overall, we would have 3 equations. And 3 unknowns, E1, E2, and E3. I have already calculated E1, E2, and E3. So E1 will be 8 volts, E2 will be 9 volts, and E3 will be 1 volt. And we found the any variable. So the question asked us to find the power absorbed by the 3 ohms resistor. So for the power for the 3 ohm resistor, the formula we have is V squared over R. So V here will be E2. So it will be E2 square over 3, which will be 9 square over 3. And it is equal to 27 watts. So we found the answer for this question. And I hope that this video was helpful for the students. And thanks for watching.